You think energy moves. You imagine it flowing, like water in a pipe, from one place to another. That picture feels obvious. It feels natural. And it feels correct. But it is wrong. Energy does not move the way you think it does. And once you understand this, you will never look at wires, heat, or even your own body in the same way again. Let us begin with something familiar. You flip a switch. The light turns on, so you assume energy traveled from the power plant, through the wires, and into the bulb. That seems reasonable, but if energy really moved like that, the world would behave very differently. In fact, many devices you use every day would not work at all, so we need to slow down and look at this idea carefully. Most people imagine energy as a substance, something that flows, something that gets stored, something that gets used up, something that goes from one place to another. We even talk this way. We say energy flows through the wire. We say energy goes into the system. We say the battery sends energy. But language can be misleading, because when physics looks closely, energy does not behave like a moving thing. Here is the first idea that feels strange. Energy is not a thing. Energy is a number. It is a way to measure change. And numbers do not move. 7 does not travel. 10 does not flow. Numbers only change when the situation changes. Keep this idea in mind. Now let us talk about heat. You touch a hot cup of tea. Your hand gets warm. You say heat moved from the cup into your hand. But what actually happened? The tiny parts inside the cup were moving fast. The tiny parts inside your hand were moving slower. When they touched, their motions changed. Some slowed down, some sped up. That is all. No heat substance jumped across. Nothing traveled from the cup into your hand. Only motion changed. Energy did not move. Energy was reassigned. This is where your intuition pushes back. Your brain wants energy to behave like a fluid. But nature does not care what feels comfortable. Now let us talk about electricity. This is where the mistake becomes clear. You plug in a device. It turns on almost instantly. But the tiny charged parts in the wire move very slowly, sometimes slower than walking speed. So ask yourself this. If energy is carried by moving charges, how does the device react so fast? It should not, but it does. This tells us something important. Energy is not riding inside the wire like water inside a pipe. What actually happens is different. The energy transfer happens around the wire, not inside it. It happens in the space near the wire. When you flip the switch, the electric field changes. That change spreads quickly through the whole circuit, almost as fast as light. The wire is not a pipeline, it is more like a guide. The energy transfer is linked to changes in the field, and fields are not objects, they are descriptions of space. Once again, energy is not a moving thing. Here is the key point. The charged parts move slowly. The energy transfer happens fast. So energy cannot be carried by the motion of those charges. Energy is tied to change. Change in motion. Change in fields. Change in how systems behave. At this point, people often ask a question. If energy does not move, then where does it go? The answer is simple but uncomfortable. Energy is tracked. You define a system. You measure before and after. You compare the difference. Energy is conserved because the numbers balance, not because something physical slides through space. Think of a bank app. You send money to someone. Did physical cash move? No. Numbers changed in 2 places. Energy behaves more like that than like a flowing liquid. This idea matters, because once you stop thinking of energy as a moving substance, many confusing things become clear. Why machines work the way they do, why heat behaves strangely, why electricity feels instant, why physics avoids simple flow stories, and why intuition fails. So far, we have only scratched the surface. We looked at heat, We looked at wires. We looked at fields. But the real shock is still ahead, because once you accept that energy does not move the way you imagined, you are forced to ask a deeper question. If energy does not flow, then what actually changes? And what does it really mean to say something has energy? That is where things become uncomfortable. And that is where we go next. In the next part, we will look at why batteries do not store energy the way you think they do, why motion alone does not explain energy, and why the idea of using up energy is deeply misleading. Stay with this, because once you see it clearly, you cannot unsee it. Now let us continue. Earlier, we said something that feels strange. Energy does not move like a thing. It does not flow like water. It is not carried the way we imagine. So now we must face a question. If energy does not move, then what does it mean to store energy? Let us talk about batteries. Most people think a battery is a container. They imagine energy sitting inside it, waiting to be released. That picture is wrong. A battery does not store energy the way a tank stores water. What a battery really stores is a difference. Inside the battery, the tiny charged parts are arranged in an uneven way. They are separated. This separation creates a condition. When the circuit is closed, that condition allows change to happen. The battery does not send energy out, it allows energy transfer to occur in the rest of the system. The energy change happens in the device, in the wire, and in the surrounding space, not inside the battery alone. The battery is more like a setup, a starting point, not a box full of energy. Now let us talk about motion. You often hear that moving things have energy. A rolling ball, a flying arrow, a moving car. This is true, but it hides something important. Motion alone is not enough. Energy depends on comparison. Compared to what? A moving train has energy relative to the ground. But to someone inside the train is not moving at all. So does the energy disappear? No. The description changes. Energy is not an absolute thing. It depends on how you choose to describe the system. This is another sign that energy is not a substance. It is a way of accounting for change. Now think about this idea of using up energy. People say energy is consumed. They say energy is lost. But in physics, energy is never destroyed. It only changes form. So what does using energy really mean? It means energy becomes spread out. It becomes less useful, less able to cause change. This is where heat comes back. When energy turns into random motion, it is harder to organize, harder to use. Not gone, just less available. This is why engines heat up. This is why machines wear out. This is why nothing is perfect. Energy is conserved. Usefulness is not. This leads us to an idea that feels uncomfortable. The universe does not lose energy. It loses order. And that is why things happen the way they do. This is also why time feels like it moves in one direction. But we will leave that for another video. Now let us return to the main point. Energy does not travel like a package. It does not flow like a river. It is a bookkeeping tool, a way to track change across systems. When something happens, energy helps us describe it. Not because energy is doing the work, but because the description works. This is why physics relies on energy so much. Not because it is real in a physical sense, but because it never fails. It always balances. This idea feels unsatisfying at first. Your brain wants a thing, something you can picture. But nature does not promise to match your imagination. It only promises consistency. Once you stop asking where energy goes and start asking what changed, everything becomes clearer. Wires stop being mysterious. Heat stops being confusing. Motion stops being absolute. And energy stops being a substance and becomes what it really is, a powerful way to understand change. So the next time someone says, energy flows through a wire, remember this. What really flows is change. Energy is how we keep score. And that simple shift in thinking is enough to break most of your old intuitions about the world. That is not a weakness, that is learning. And once you see it this way, you cannot unsee it.